These are the microscopes that we're using this year. I'm going to go through the parts of it, how to care for it, and how to calculate magnification. First, up here is the eyepiece. This is where you look through with one eye. The top part does twist a little bit to help get things a little bit in focus. However, we don't really have to use that too often. And it does rotate. Moving down, here are your objective lenses. Each one magnifies a little bit more. They click into place. I don't know if you could hear that, but they actually click. You want to make sure that you have it clicked in place, because if you're between clicks, you're not going to be able to see anything. Underneath that, where the slide goes, is called the stage. And some stages have a little arm that holds everything in place. And I'll give you the name of that later. This one, it's broken, so it doesn't have one of those little arms. But your slide sits on here, and then we can move the stage up and down, as we'll talk about shortly with these knobs. Before we get there, down here is the light source. This illuminates whatever you're seeing, so as you're looking through the microscope, you can see it. If this was plugged in right now, which it's not, your on-off switch would be on the back, and that would turn my light on or off. Here we have two knobs, and as I mentioned before, they move the stage up and down. This one, the big one, is called the Coarse adjustment knob and moves the stage very fast. So that's fine if I'm on this low power to do this, move it quickly. If I am up on a higher power, however, you can see if I move this too fast and I'm not careful, I could crash into my slide. So when you're on a higher power, you should only use the little knob, which is called the fine focus. When you get something in focus under the low power and then switch to a higher power, you shouldn't have to move this knob anyway. You should only have to do minor adjustments using the fine focus. Next, we have the stage clips, which again, this one's missing it, but on some microscopes, well, you can see it on the other side, I suppose. This is one stage clip. It's going to help hold your slide in place. And you can actually move where the slide is side to side and up and down, like so, using these knobs. So if I had a slide sitting in here right now, this would move the slide forwards, backwards, and side to side. These don't have any specific names that I need you to know, but I would like you to know stage clips. Up here is the arm. This is where you hold the microscope to carry it, and you're always going to use two hands. So speaking of that, let's go to the questions that are on the other side of your page. It says, how many hands should you always hold it with? Two. You put one under the arm, or one on the arm, and one under the base. You should always start on lowest power on this red one, because, again, we don't want to try and get things into focus under a high power. It's too difficult. Always start on low power. When you're on medium or high power, which knob should you never use? You should never use the coarse adjustment, the big one. When you're done, to reset your microscope for the next group, you put it on low power. You make sure the stage is all the way down as far as it'll go, and then you wrap the cord around the base. Now I can't really do it too well right now because I'm holding my tablet in one hand, but when you get a microscope to use, you'll see the cord wrapped up around the base down here. So please do those three things, plus turn off the light. So on your sheet, low power, stage down, wrapped cord, light off. And if you do not take care of my microscopes properly, that will end you up in detention. So please be careful. They are very expensive, and it allows other people to use them as well. Now to calculate magnification, it's pretty simple. So we're looking at a slide and you want to know how many times bigger is it than what you can see with your eye. The eyepiece multiplies everything times 10. And then each lens multiplies it even further. So starting with the blue lens, which is over here. Okay, I don't have it under where you'd be looking through right now, but you can see it has a number on it, maybe because of the light. There we go. It is 40. So the blue lens multiplies everything by 40. If you were looking at something like so, it would be 10 times 40, which would be 400 power. Medium power, the yellow, doesn't really have the writing on the side that's good for you to see. You can see it a little bit there. Yellow multiplies everything by 10. So if you're looking at something under medium power, you're seeing 10 times 10 would be 100 times bigger than normal. Low power red is times 4. So if I had this in place, you'd be seeing 10 times 4 would be 40 times bigger than normal. To calculate, as I've been going through examples here, you're just multiplying the magnification of the eyepiece, 10, times the magnification of the objective lens, which is either 4, 10, or 40. So, do a sample problem. Let's start with low power. Let's say you're looking at something under low power. How do you do it? The eyepiece multiplies it by 10. And low power, the objective lens is what? Hopefully you said 4. 10 times 4 equals 40. Calculate the magnification for high power. If you're stuck, the eyepiece is 10, that's always the same, times high power is 40, so therefore your magnification is 400 times. Medium power would be 10 times 10 is 100. In your note packet you should see what you have to do next. You're going to be completing the microscope lab. If you need any help, let me know, and if you're ahead of everybody else, you need to give me at least a day's warning so I can get this lab set up for you.